This is part 2, or part B of lesson 2.4, starting on page 86. And we're going to talk about angle of elevation and angle of depression. These are really important terms that you get. You have to have this vocabulary, okay? So the angle of elevation is measured upward from a horizontal, okay? Elevation, it's going up. So you have a horizontal line here, okay, down the bottom, and the angle of elevation is you looking up at something. So this is the angle of elevation here, and I can't turn my little highlighter sideways to color in there, but maybe you can. And then we have the angle of depression. Well, depression is down, so that's us going down from the horizontal. So here's where my eyeball is. Here's my horizontal line, and my angle of depression is looking down at something. In this case, I'm looking down at the boat. And so that's the angle of depression, okay? Now, note that this is so important here. This piece is so important. Angles of elevation and angles of depression are determined from the horizontal. They're compared from the horizontal. They're not from the vertical. That's really important. You're always starting off with the horizontal and then looking down or looking up. And so here we have, this is the angle of depression, and here they have the angle of elevation. And notice that they are equal, okay? They're the same thing because this horizontal line, the lines are parallel. So those two angles are equal, and that's super important. Let's do an example. So we have a tree that casts a 5.1 meter, the tree's 5.1 meters, and the shadow is 7.5 meters, and we want to calculate the angle of elevation of the sun. So here's a little thing that you need to know for this, that if you draw this and you keep on going, this is where the sun will be. My grade 2 drawing of the sun, okay? So we are looking for this angle, theta. And then if I do my hypotenuse, oops, I'm not going to circle that. My hypotenuse, my opposite, and my adjacent, I can see that I'm going to use tan, because tan theta equals opposite over adjacent. So tan theta, and I'm just going to use theta because that's as good a variable as anything for an unknown angle, is going to be 5.1 over 7.5. So theta equals tan to the minus 1 of 5.1 divided by 7.5, and that tells me that theta equals 34.2 degrees, because they did ask us to do that to the nearest tenth of a degree. Okay? All right. Another example. It asks us to draw a diagram of this. So we have, here's my cliff, and my cliff is 80 meters tall, and a boat is 130 meters away, and here's my boat. It's a sailboat. There we go. There's my little sailboat, okay? And we want to know the angle of depression to the boat from the top of the cliff. So they are asking us to find this angle. This is the angle of depression. But the angle of depression is the same as this angle here. Okay, that's how you're able to do this question. So I'm going to notice too that I drew this kind of to scale. Like if this was 80, that's, well, it's probably a little bit longer than it should be, but I didn't make this one 80 and do one here where this was 130. It's to scale-ish, okay? So this is my angle of interest. Here's my hypotenuse. Here's my opposite. Here's my adjacent, and I can do my circling. And, oh, I've moved into the next question already, actually, of part B. Figure out what the angle of depression is, okay? So I guess the drawing should have just stopped with angling. With labeling, this here is the angle of depression. Terrible writing today. Okay, but now that I've done my circling up, I've got opposite and adjacent. That means I'm going to use tan, because tan theta is opposite over adjacent. So tan theta is going to be 80 over 130. So theta is 32 degrees. Okay? All right, now this one requires a little bit of thinking. Consider isosceles triangle KLM. So what the heck is an isosceles triangle? Isosceles means there are two equal angles and two equal sides. So since they tell us in this drawing that KL is 20 and LM is 20, then I know that this angle equals this angle, okay? I also know that if I split this in half, or split this down the middle, this is going to be half and this is half. So since I'm going to label this N, and if Km is 30, that's not really helpful to me, but it is helpful to know that Kn equals Nm, and they both equal 15. So that's what I'm actually going to label on my diagram, because now I have a couple of right triangles, right? And I skipped ahead as well. I'm sorry. Why can't we use sine, cos, tan, or SOHCAHTOA in this triangle to figure the measure of KLM, or angle KLM? It's because it's not a right triangle. So we can't use it directly, or we can't use it yet. We need to find a right triangle in it, which I've already kind of jumped ahead and done. Okay, so now we're going to determine to the nearest degree how big is angle KLM. So since KLM is up here, and my calculation is going to be based on this, I'm actually going to set something up to make this easier for myself. And that's what I'm going to come over here, and I'm going to say, well, angle KLM is going to equal it's going to equal 2 times theta. And I'm going to label this as theta, and this is also theta. Those are going to be equal. So that means it's going to be 2 times some number. I don't know what it is yet. And then when I multiply that, I'm going to have a number. And then I'm probably going to round it. So and my final answer is going to be in degrees. And I'm going to circle this because this is going to be my answer. And I'm not finished until I have something in that spot. So this is a trick that I use. Well, I think I've spoken about this before, a couple things. I've done it before because it helps me remember to put my units in, which is really good. This one, it's really useful because I'm going to calculate theta, and I don't want to calculate theta and then forget that I have to multiply it by 2 to find what I actually want. So I'm just putting that right here, and then I just have to fill in my numbers and then do it. And I don't have to do that thinking piece, and I don't have to remember all of that. So this works really well for me, and it's worked really well for everybody that I've shown it to who's actually done it. So you make a decision on that. All right, I'm just going to copy my triangle out again. So I know that this side is 15, this side is 20, and I'm looking for this angle here. So this is my angle of interest, this is my hypotenuse, this is the opposite, this is the adjacent. Since I have opposite and hypotenuse, so that's going to be sine theta is opposite over hypotenuse. So sine theta is going to be 15 over 20, and I get theta equals 49.59037789. Now, do I need to write all of those down? No, but I do, because if I'm using this number a couple of times or I mess up on my calculator or whatever, sometimes it's easier just to have it written down, and it doesn't take any time to write it down, okay? What I'm going to do now is I'm going to take this, since this is my theta, and I'm going to plug it in over here. I'm not going to write the whole thing again. I'm just going to write 49.59, but I am going to keep all digits for the calculation. It's just sitting in my calculator, I never hit my calculator clear button, sorry. I don't hit the clear button until I need it again. I'm just going to leave whatever my last calculation was until I have to clear it. That way I still have this number sitting in my calculator, so I just go times 2, and I get 97.18. And I was asked to do this to the nearest degree, so I'm going to round that to the nearest degree, which is going to be 97 degrees. I already have my degree sign in there. I don't have to think about it, and I know that I'm finished my question. Okay, that's it. Go do the rest of the questions. See you in class. Bye.